So beta, as I told you, first we will be going into the concept of running fix, and then we will see how this concept is applied to position lines and position circles.
To benefit the most from this video, kindly be comfortable with the concept of position lines, position circles, allowing wind, allowing current, allowing both wind and current. Now, all these have been covered in the earlier videos in our series. If you feel that you need to brush up any of these topics, please do watch those videos before going ahead with this one.
So these are all the topics which we have covered till now. Position lines, position circles, allowing and counteracting for wind and current. All these we have covered up. So in running fix, we will be using all these concepts. ये सारे के सारे जो कॉन्सेप्ट हैं ये रनिंग फिक्स में अब एक साथ यूज होंगे.
Be able to fix the vessel's position by simultaneous observations. That is, the observations which are taken at the same time. We must have minimum 2 position lines or minimum 2 position circles or minimum 1 position line and 1 position circle. Now, there may be situations wherein simultaneous observations are not available. However, staggered observations taken at different timings may be possible. These staggered observations may be in any combination. They could be position lines, position circles, or 1 position line and 1 position circle.
So let us just go through these points one by one comfortably and let me know your doubts. So clear beta, no doubts?
Clear, sir.
Okay, all right.
Obviously, as the observations happen to be staggered, both these observations would be for different timings. If the displacement vector of the vessel over the ground, that is, her course made good and distance made good during the interval between the 2 observations is known, the first position line or the first position circle, as the case may be, can be run up or transferred to the time of second observation. The vessel's course made good and distance made good shall allow for the factors which are responsible for the vessel's displacement during the interval between the 2 observations. And these factors could be any one or all of the following. Vessel's propulsion vector, represented by course to steer and the engine distance covered during the interval. Wind, affecting its leeway, and the current affecting through set and drift during the interval. The intersection of the transferred PL or PC with the second observation, which again could be a PL or PC, fixes the vessel's position at the time of second observation. This method is known as running fix, wherein you have allowed the run of the vessel or you have run up first observation PL or PC.
Okay, so beta just go through these points one by one. Let me know your doubts. Clear beta, all clear? Beta, everything okay?
Yes, sir.
Okay.
Yes, sir. Okay.
ये सुबह वाले लेक्चर में आवाज बहुत कम आती है ना, डाउट भी बहुत कम आते हैं. So, okay. So this was the concept of running fix. So were you able to understand, beta?
Yes, sir. Yes, sir.
Okay. So can anyone tell me what is a staggered observation? Anyone?
Sir, position line or take at different times.
Very good, Ankit. So that is known as a staggered observation. Running fix concept is based on a staggered observation. अगर हमें दो पोजीशन लाइंस मिली हैं अलग अलग टाइम पे और हमने उनको कंबाइन करना है, हमने उनको ज्वाइन करना है, दैट इज व्हाट वी कॉल एज ए रनिंग फिक्स. सो ज्वाइन करने के लिए एज वी सॉ इन द वीडियो, so let me show you again. So as you see, we have to allow for vessel's CTS, the leeway of the wind and the set and drift of the current. So we apply this to one of the PLs and transfer it or run it up to the time of the second PL, and then it can be used to fix up the vessel's position. So that was the concept of running fix. Now we can move on to how do we use this running fix concept in case of a position line. So let me show you now. How do we apply running fix to a PL? Okay, so we are now going to see the running fix concept on a position line, and इसमें हम कौन से concept use करने वाले हैं? We are using these concepts: PL, allowing for wind, allowing for current, and the concept of running fix which we just now saw. So let's proceed ahead. Just give me 1 minute. बेटा ये जो हमारा ट्रांसफरिंग ऑफ पोजीशन लाइन का वीडियो है, इसकी जो ऑडियो है वो थोड़ी सी लो है, सो आई वुड रिकमेंड कीपिंग योर वॉल्यूम टू द मैक्सिमम. If you have headphones, it is better to use headphones. The audio quality is little low. Okay. I will try to improve it as much as possible, but you keep your volumes up. Okay, let's go. I tried to improve the volume as much as possible. Let's see.
This one. Only straight line PLs can be transferred. Thus, this method does not apply to non-straight line PLs like the PL by depth contour. One method of drawing a unique straight line, as learned under the video on PLs, is to know a point through which to draw the straight line and the direction of the straight line.
Are you able to make out, beta? Whatever
Yes,
is
sir.
being, okay, all right. Whatever is being spoken is coming in text also. So if you are not able to hear anything, you can just see what is written here and you will be able to catch up. Let's see.
In context of the PL, this becomes a point through which to draw the PL and the direction of the PL. To transfer a straight line PL, we transfer any point on the PL. We take up any point of our choice. We run it up for the duration for which the PL has to be transferred. And the transferred PL is then drawn through this transferred point, and the direction of the transferred PL is the same as the direction of the PL being transferred or the first PL. The transferred PL is indicated on the chart by two arrows at each of its free ends with time to which it is transferred indicated against it.
Just go through these points, beta, one by one. Let me know your doubts. Clear, beta? चलें आगे?
Yes, sir.
Okay, we will see this actually on the chart. We will take a practical question and then plot it on the chart using this method.
Now let us list down the methods for transferring the PL. So the steps are listed down in sequence. Take any point on the first PL, any point of your choice. Imagine the vessel to be at that point. Well, we know that we only have a PL, we do not have the position. Vessel could be anywhere on the PL, but we just imagine the vessel to be at that particular point, because then it will become easier for us to remember and execute the process. Determine the position where the vessel would have reached from its assumed position at the end of the interval for which PL is being transferred. The position thus obtained is the position to which the point on the PL, the assumed point on the PL, is transferred at the end of the required interval. Through this transfer point, draw a line parallel to the first PL. This line drawn parallel to the first PL through the transfer point is the transferred PL. Indicate the transferred PL with two arrows at each of its ends. Also indicate the time to which the PL has been transferred.
Beta, let me know your doubts in any of the points. We will be doing this method on the chart now.
सर ये पॉइंट नंबर 4 बताना.
ओके बेटा, इसमें क्या डाउट आ रहा है?
सर फर्स्ट पीएल में पहले एक पॉइंट अज्यूम कर लेंगे आप.
राइट, दैट्स राइट.
उसके बाद में जो भी टाइम ड्यूरेशन है और जो अपना सीटीएस होगा उसको सर ट्रांसफर कर लेंगे सर अपने टाइम ड्यूरेशन के लिए.
राइट बेटा.
ऑन द सेकेंड पीएल.
सेकेंड पीएल अभी है नहीं हमारे पास. वी विल गेट ए पॉइंट, दैट्स ऑल.
ओके.
ओके,
यस सर.
डाउट क्लियर हो गया बेटा?
नहीं सर, सर क्वेश्चन करेंगे तो भी सर समझ में आएगा ये थोड़ा.
ओके, ऑल राइट, ठीक है बेटा. अभी हम लोग एक क्वेश्चन करेंगे वेयर वी विल यूज एग्जैक्टली दिस मेथड एंड सी हाउ इट इज ट्रांसफर्ड.
यस सर.
So now the only thing we need to know is how do we transfer up the assumed point on the first PL. Of course, we take any point. The point can be any point of your choice. We imagine the vessel to be at that point, as already said earlier. Now, if we have to find the vessel's position at the end of the required interval, then we need to allow for the forces which cause displacement to the vessel. So all the displacement vectors or forces causing displacement of the vessel need to be allowed for. And what are these forces or vectors? One is because of the ship's own propulsion, represented by the course to steer and the engine distance. The other could be because of the wind, which is applied through its leeway. The other could be current, which gets applied or allowed through its set and drift. Now, in each case, you may be experiencing either one of these factors, two of them, or maybe all of them. So depending on how many of these are applicable in a given scenario, we allow for that many factors and find out the position where the vessel would have reached from its assumed position on the first PL. The position thus obtained is the transferred point. For transfer the first PL through this transferred point to obtain the transferred PL.
Okay, so this is the stepwise procedure which we are going to follow in these questions. Shall we move ahead, beta?
Yes, sir.
Okay.
Now let's look at this entire exercise through some examples so that we allow for these factors in different combinations. A vessel steering 070 degrees true at 12 knots observes Roche's point light bearing 010 degrees true at 2000 hours. At 2130 hours, it observes Belly Cotton Island light bearing 320 degrees true. If there was no wind or no current, During the interval, find the vessel's position at 2000 hours and 2130 hours, CMG and the SMG. So we start with the identification of the landmarks. So here we have identified this is Roche's Point and this one is Pellicotton Island. You can see where these boxes have come up.
Beta, is the question clear? Any doubt in the question?
No, sir.
Okay, very good. You can see, beta, in the question 1 PL is given for 2000 hours and the second PL is given for 2130 hours. So these are for different times. There is a difference of 1.5 hours. So this is a very simple question. There is no wind, there is no current in the area. And we now need to know what is the vessel's position at both these times. The speed is given to us 12 knots, course steered is given to us 070. The bearings at both the times are also given to us. So let's see how do we plot it.
We draw the first PL of 2000 hours. This is the first PL. We draw the 2130 PL, indicated time against it. Now we pick up any point on the first PL. So this point A is any randomly selected point on the first PL. Now the vessel is experiencing displacement only because of her own propulsion, as the problem statement says no wind and no current. So through A, we draw CTS. This CTS is represented by single arrow, you can see. The magnitude of this vector shall be the engine distance for 1.5 hours, interval between 2000 hours and 2130. So at 12 knots, the distance becomes 18 miles. So from A, we mark off 18 miles and we get point B on the CTS line. Now B, we all know, would be the DR position of the vessel. But in this particular case, since there is no wind, no current, so this also happens to be CMG line. So you can see two vectors coming up on this line. So this is CTS as well as CMG line. And distance AB is the engine distance and also becomes the distance made good in 1.5 hours. So because vector AB is CMG line and distance AB is the distance made good, so point A is transferred to point B. So through B, we transfer the first PL. You can see it here. The transferred PL in red is represented by two arrows at each of its end. You can see time for 2130 indicated against it. So now we have one transferred PL for 2130 and we already have another PL for 2130 where they intersect. This becomes the vessel's position at 2130. So point X represents the position of the vessel at 2130. Now, how the vessel would have reached this point X? Vessel would have reached point X by making good a course whose direction is represented by AB, CMG. So that means the vessel would have reached point X by traveling over a track represented by AB direction and passing through point X. Now this one. So that means the vessel would have basically traveled along this track, which is the CMG track, and at 2130 reached out here. So that means the vessel would have been here at 2000 hours. So where this CMG transferred through point X cuts the 2000 hour PL, this becomes the 2000 hour position. So point Y is the fix at 2000 hours. Point X is the fix at 2130. Y to X direction represents CMG and distance Y to X represents distance made good in 1.5 hours. When this distance made good is divided by 1.5 hours, it shall give us the speed made good by the ship in knots.
So beta, have a good look at the plot. Let me know any doubts coming to your mind.
सर अगर इसी क्वेश्चन में विंड या करंट हमें दिया होता तो जो हमने ए बी बनाया है वो हमारा सीएमजी और डीएमजी डिफरेंट होता, तो उसके रेस्पेक्ट में जहाँ पे मेरा सीएमजी और डीएमजी कट कर रहा होता इस लाइन पे, तो मैं वहां पे पीएल ट्रांसफर करता मैं अपनी।
दैट्स राइट बेटा, दैट्स राइट। मैं आपको आगे अभी विंड और करंट के साथ भी प्लॉटिंग दिखाऊंगा, बट जो आपने बताया है दैट इज करेक्ट।
ओके सर।
ओके, और बताओ बेटा, और डाउट्स?
नहीं सर।
क्लियर बेटा, ऑल क्लियर?
सर जो हमने मारी है पहले बेरिंग्स लिए दोनों, तो उस पे एक सिंगल सिंगल एरो नहीं आएगा?
डाल सकते हैं बेटा, बियरिंग पे यू कैन पुट सिंगल एरो, 2130 के पास, यहाँ 2000 के पास यू कैन पुट सिंगल एरो।
ठीक है सर।
Okay, so all clear up to here?
Yes sir.
Very good beta. So this is a basic question on the concept of running fix. So हमने इसका एक basic जो है ये understand कर लिया है. Let's see ahead.
In this case, of course, CTS and CMG are same, engine distance and distance made good are same. Why? Because there was no wind and no current. So you can see other notations also showing up. Let's.
Okay. अब बेटा मुझे ये बताओ आप, हम लोग अब इसके आगे इस क्वेश्चन में विंड और करंट को डालने वाले हैं। सो पहले हम लोग विंड को इंक्लूड करेंगे, फिर उसके बाद करंट को इंक्लूड करेंगे, फिर हम दोनों को इंक्लूड करके देखेंगे कि ये प्लॉटिंग कैसे होती है। सो ये अब हम करने वाले हैं। नाउ यू टेल मी, बिकॉज इट्स अबाउट 8:45 नाउ, नेक्स्ट क्लास आपकी 9 o'clock है, you want to go ahead with the wind application or you want to stop here?
कर लेते हैं सर ट्राई।
ठीक है बेटा, ओके। सो आई एम गोइंग अहेड विद विंड नाउ।
Take another scenario. Vessel steering 070 degrees true at 12 knots. Observes Roche's Point light bearing 010 degrees true at 2000 hours. At 2130 hours, it observes Ballycotton Island light bearing 320 degrees true. Same as before. If during this period it experienced northwesterly wind causing 3 degrees leeway but no current, find the vessel's position at 2000 hours and 2130 hours, CMG and SMG. As you can see in this question, that we'll have to allow for ship's own propulsion vector and also we'll have to allow for wind. So let us see how do we allow for the wind, which we've already covered earlier under allowing wind and current. But let's quickly allow for wind and proceed with the question. So we identify the two landmarks, of course. These are the two PLs.
Now beta, in this question you see rest all. In this question you see rest all the items are exactly same. The only difference is that we are having a northwesterly wind and it is causing a leeway of 3 degrees. That is the only difference. There is no current in this question. So we will see how do we transfer the PL now.
Which we have already covered in the first discussion. We take any point. Now this light green vector which you see is the CTS vector 070 degrees true. Vessel is experiencing northwesterly wind, that means wind is coming from northwest. So northwesterly wind would be as represented.
Beta, can you tell me what will be the leeway track effective course in this case?
073.
Very good, beta. It will be 073.
By this arrow, wind arrow now in the diagram. Now, since we have to allow for leeway, please remember we have to allow for leeway. When we allow for leeway, leeway is factored or allowed to the lee side of the vessel or to the downwind side. In this case, you can see the starboard side of the ship is the lee side, so the leeway is factored onto the starboard side. You can see 3 degrees of leeway showing up on the screen, and what you get with dark green line is the leeway track or the effective course track, which is also represented by single arrow, and you can see in this case the leeway gets added to CTS to give us the effective course. As also explained in the video on allowing for wind and current, on chart we may prefer not to plot both these vectors because they will unnecessarily clutter the chart. So if you wish, you may allow for wind on the answer sheet, as you can see the steps showing up in the box. CTS 070 degrees true, leeway 3 degrees, northwesterly wind. Why the wind direction is being reiterated here? Because it has to be seen in conjunction with the CTS to decide whether leeway is to be added or subtracted. And so the effective course becomes 073 degrees true. So what we'll do is we'll restart our plot.
So up to here, I hope everybody is clear, beta. Any doubts?
No, sir.
Yes, sir.
Very good, beta. Very good.
Instead of drawing CTS, we'll draw the effective course of the leeway track of 073 degrees true. And of course, the magnitude of this, as already explained in the earlier videos, would be the engine distance for the required duration. So now we start with the effective course of 073 degrees true. Landmarks identified, both PLs plotted on the chart. We take any randomly selected point on first PL, and this time what we draw through point A is the effective course of 073 degrees true. This will also be represented by single arrow. The magnitude of this would be the engine distance for 1.5 hours, that is 18 miles. We get point B. That means the vessel from A would have reached point B after 1.5 hours because she would be moving along her effective track. So this also happens to be her CNG line. So point A, as already explained, is transferred to point B. In the previous discussion, where there was no wind, it was a 070 degrees true into 18 miles track. This time it is 073 degrees true into 18 miles. Point B is to the point to which A is transferred. PL is transferred through B, marked with 2 arrows at each end. Time of transferred PL indicated, and this is the 2130 fix, X is 2130 fix. Now the CFG line represented by AB transferred through X, giving us position at 2000 hours, that is point Y. So Y is the 2000 hour position, X is 2130 hours position, Y to X direction is the CMG, which is 073 degrees true in this case, and Y to X is the distance made good in 1.5 hours, which will lead us to speed made good.
So beta, just have
सर
a good
क्वेश्चन
with. बोलो बेटा.
सर जो मेरा XY डिस्टेंस होगा वो 18 माइल्स होगा सर.
That will be right, beta.
That will be the same course 073 and 18 miles.
That's right, beta. XY will be exactly parallel and same as AB. AB और XY दोनों बेटा सिमिलर वेक्टर्स हैं, दोनों का मैग्नीट्यूड और डायरेक्शन सेम है.
ओके सर.
ओके, और डाउट्स बताओ बेटा. Okay, very good. Clear, beta. Shall we move on to current also?
Yes, sir.
Okay, all right.
To speed made good. Now, let's take up the questions. Same problem, only thing is this time no wind, but experiencing current. A vessel steering 070 degrees true at 12 knots observes Roche's point light bearing 010 degrees true at 2000 hours. At 2130 hours, it observes Pellicotton Island light bearing 320 degrees true, same as earlier cases. If during this period, it experienced current setting 180 degrees true at 2 knots, but no wind, find the vessel's position, CMG and SMG.
So beta, only difference here is we have a current in the area, there is no wind. Rest everything is same.
Now, as already explained during the allowing of wind and current, we have to ask ourselves a question, are we going to counteract current or allow for current? In this case, we have seen.
Can you tell me, beta, will it be allowing or counteracting?
Allowing for current.
Allowing,
Very,
sir.
very good, beta, very good.
CTS, CNG is to be found, so it shall be allowing for current. There's no wind, so the two displacement vectors are one because of ship's own propulsion and the other is because of the current. So let's get going with the question. We'll identify the landmarks. We draw the 2000 RPL. We draw 2130 PL. We take any point on first PL. Now we draw the CTS through it, indicated by single arrow, mark off engine distance for 1.5 hours, that is point B. So this is 070 degrees true into 18 miles. Now we have to allow for current. I hope you remember when you allow for current, the current is applied at the DR position or the arrowhead end of the CTS line. That means now the current has to be allowed at point B. So we allow the current here, represented by 3 arrows. The rate of the current is 2 knots. So in 1.5 hours, the drift would be 3 miles. So we mark off from B 3 miles on the current sector vector and we get point C. D to C is 180 degrees true and 3 miles off. So A to C now gives us the CMG and A to C gives us the DMG in 1.5 hours. So if the vessel was at point A at 2000 hours, then because of her own propulsion and the current, in 1.5 hours, that is 2130, the vessel would have reached point C. That means point A stands transferred to point C. So this time the PL shall be transferred through point C. So we transfer the PL through point C, indicated by 2 arrows at each end, time indicated against it, and where it cuts the 2130 PL, that becomes point X, the 2130 fix. Again, like the previous questions, she would have moved along her CMG track in reaching this position. So we transfer the CMG through 2130 position, where it cuts the 2000 PL, that becomes point Y and 2000 fix. So in this question now, point Y is fixed at 2000 hours, point X is fixed at 2130 hours, Y to X is the CMG, and Y to X is the distance made good in 1.5 hours, when divided by time of 1.5 hours shall give us the speed made good.
So beta, have a good look at the plot. Let me know your doubts.
सर ये पॉइंट बी भी इमेजिनरी पॉइंट है?
नहीं बेटा, इमेजिनरी तो नहीं है. B is our DR position basically. देखो हमने अपना CTS लगाया है 070 और 18 माइल्स एट पॉइंट ए.
यस सर.
So yes, in a way you are right because जो A point है ये हमने बेटा any point on the PL लिया था. So B and C both are assumed points. They can be anywhere on the chart.
तो सर बी और सी को, बी को हम कहीं भी मार्क कर सकते हैं ना सीटीएस पे.
हाँ बेटा, अगर आप A की पोजीशन को चेंज कर दोगे तो B और C भी ऑटोमेटिकली चेंज हो जाएंगे.
ओके सर.
ओके, और बताओ बेटा, और डाउट्स?
प्रीवियस क्वेश्चन में जो हमने लाइन जो सीटीएस ड्रॉ करा था, तो सेकेंड पीएल पे जो कट कर रहा था उसे हम बी ले रहे थे.
नहीं बेटा, लेट मी गो बैक. विंड वाले क्वेश्चन की बात कर रहे हो आप?
यस सर.
ये देखो बेटा, दिस वाज वेयर बी वाज. ये रहा पूरा प्लॉट. यू सी पॉइंट ए पे हमने अपना इफेक्टिव कोर्स और इंजन डिस्टेंस अप्लाई किया था. दैट्स हाउ
Yes.
वी गॉट दिस पॉइंट बी.
ओके.
ओके.
यस सर.
ओके बेटा, गुड. और भी कोई डाउट्स आ रहे हैं बेटा माइंड में? एनी मोर डाउट्स?
नो सर.
वेरी गुड. सो बेटा हमने एप्लीकेशन ऑफ विंड भी देख ली है, हमने एप्लीकेशन ऑफ करंट भी देख लिया है. सो आवर टाइम इज़ अप फॉर दिस सेशन. अगले सेशन में हम विंड और करंट दोनों को एक साथ अप्लाई करेंगे. सो विंड एंड करंट दोनों को एक साथ अप्लाई करेंगे एंड वी विल सी हाउ डू वी अप्लाई दिस रनिंग फिक्स कॉन्सेप्ट. ओके, so that's all for this particular session. See you in the next session.
So can we get some practice exercise for the position circles?
Practice assignment बेटा.
So yeah, regarding the position circles.
मैं बेटा आपको भेजने वाला हूँ, पर मुझे एक और छोटा सा कॉन्सेप्ट आपको कराना है. So once that concept is done, I am going to send you the practice questions.
Okay, sir. Thank you.
Okay. Okay बेटा. So I will see you in the next class. Till then, bye bye.
Thank you, sir.
Thank you, sir.
Thank you बेटा. Thank you. Bye bye.